Hello, my name is Jackie Gunther. I am the third grade teacher in the Caldwell-West Caldwell School District in West Caldwell, New Jersey. Welcome to this overview of the New Jersey Student Learning Standards, NJSLS, Computer Science and Design Thinking, A.1.5, Algorithms and Programming. Overview. The development of a software program involves identifying a sequence of events, goals, and expected outcomes, and addressing errors when necessary. 8.1.5, Algorithms and Programming, is designed to teach the connection between algorithms and their impact on computing devices. The main goal of this strand is to ensure that students, number one, understand that an algorithm is a sequence of steps designed to accomplish a specific task. Number two, know that algorithms are translated into programs or code to provide instructions for computing devices. Number three, can solve large, complex problems by decomposing them, breaking them down into smaller sub-problems. Number four, programs can work more efficiently with the use of repetition, loops, and conditional statements. Number five, are able to debug or fix errors in algorithms. Number six, ensure that an algorithm program works as intended by testing it first. How to prepare. This strand is challenging because its success depends on the extent to which you have collected or developed an arsenal of examples that are translatable for your students. The following recommendations are proposed. Download the NJSLS standards and read just the strand. Focus on the material needed now. Save the rest for another day. Generate an age-appropriate playlist of YouTube videos that explain what an algorithm is and how they work. Create posters for a technology word wall. Be sure to include key computer science, math, and directional terms and flowchart symbols. Create a post-test for grade 5 and use it as both a pre-test and post-test for grades 3 to 5. Learn how to use Scratch or similar programming. This strand provides a great opportunity to review and apply math concepts like counting, ordering, and sequence, repetition and loops, directions like up, down, left, right, and turn, and decision-making or conditional statements. Locate or develop and illustrate algorithms that meet the following criteria. A, are linear in nature. It starts, goes through several steps, then ends like tying your shoes. B, are repetitive in nature. It starts and repeats itself before ending. Think of repetition like an anaphora, the repetition of words at the beginning of a sentence. For example, in the I Have a Dream speech by Dr. Martin Luther King Jr., there are two examples of repetition where the beginning of lines start the same. One is, I have a dream, and the second is, let freedom ring. C, contain a loop, which is a sequence that gets executed several times. Brushing one's teeth with an up and down motion is an example of a loop because you brush up, you brush down, repeat. D, contain conditional statements wherein your answer, yes or no, causes the program to move in a specific direction. E, complex algorithms that can be decomposed, broken down, into smaller, more manageable subproblems. F, error-ridden algorithms that require debugging, corrections in order to work. Here's a list of tasks that can be used to create algorithms. A, brushing teeth. B, tying shoes. C, getting ready for school. D, the typical school day. E, the recipe for baking cake. F, the method to solve a long division problem. G, doing laundry. H, bedtime routines. I, getting to and from a specific place like school or a grandparent's house. J, deciding what to eat. K, songs or poems that contain repetition, like row, row, row your boat. Scaffolding for students as they move from grade 3 to grade 5 comes down to one thing, the complexity of the algorithms. One way to scaffold for the material for third grade is as follows. Use the fifth grade post-test as a pretest. Let the test results dictate your starting point. Expose students to vocabulary words, math concepts, directional arrows, and flowchart symbols. Begin with a few words and then add on until all words have been included. Use entry and exit tickets to check for understanding. Begin with simple, linear algorithms using pen and paper. Move quickly to apps like Scratch. Provide handouts or wall displays that are easy for students to access. Enhance their knowledge by including sequencing and simple loops. Add more rigorous projects. A written description including the sequence, goal, and outcome should accompany every project. Cover debugging. Start with simple algorithms that are missing a step, like making a peanut butter and jelly sandwich, but the step where you get the bread or jelly is missing. Move on to more complex projects. For example, a long division problem wherein you missed a step by not bringing down a number. The marking period should conclude with the grade 5 post-test to assess where students are after year 1 of the 3 to 5 grade band. Scaffolding for 4th grade is the identical to 3rd grade with the following additions. Start with Scratch. Introduce and demonstrate use of the program. Do 2 or 3 small projects before moving to the larger culminating activity that is done independently. Written descriptions should accompany every project. Look at the grade 5 post-test data. Measure where you are and how much you will have to do to obtain an acceptable pass rate, for example, 80%. Develop a plan that targets skills students need to cover in 5th grade. Scaffolding for 5th grade. By the end of grade 5, students have seen the material and have programmed using Scratch or similar programs for 3 years. Grade 5 is the last opportunity within the band to ensure that their knowledge base is thorough and ready for the rigors of middle school computer science. Scaffolding for 5th grade is inclusive of grade 3 and 4 recommendations with the following additions. Spend an equal amount of time on the creation of algorithms and on debugging algorithms. In addition to simple loops, design projects that require an iterative process. This concludes our review of the CS 3 to 5 strand algorithms and programming. I hope you are excited to begin this journey with other teachers throughout the state of New Jersey. Most importantly, breathe. Do not stress yourself out. You will get better with planning, practice, and time.